Okay, so let's continue with module 6.3. Now we're going to add and subtract decimals. Um, so basically, the rest of this module is going to be doing the operations that we're used to. We're going to add, subtract, multiply, and divide, and then um, the the testing for this module. We're going to have a quiz where you're going to do operations by hand, and you're going to also have a test where you're allowed to use a calculator. So up till now, we haven't had any tests with calculators, but from here to the end, you will get a calculator with your test. I'm pretty sure. I think it's every test from here to the end, you'll get a calculator. But we also want to know if you can if you can do adding, subtracting, multiplying, and dividing without a calculator. So we're gonna have a short quiz. Quiz has I think 12 questions on it. So or maybe it's 6 questions and 2 points a question. It's 12 points, so it's not big. But anyway, we will add, subtract, multiply, and divide these. The important thing to do with adding decimals is you're going to have to line up the decimal point. That's equivalent to in this picture model that we had in the last video in the earlier section. Just making sure to add up, you know, I want to add these up. This is 3.68 plus 1.14, and I need to make sure that I'm adding the units together and then the tenths together, and then these. Oh no, I have 11 hundredths. Well, that's the same as having 100th and 1/10. So basically, I can take two of these here, move them here, join these into a rectangle that gets added to the number of rectangles we have. So all in all, we will end up with 4 plus 8 is not 11, it's 12. We have 12 little squares. So we will have 4.82 as our answer at the end. Because we'll join these 4 big units together, we'll join these 7 little units together, we'll join these 12 even littler blocks together, and then regroup them all. To do this in our normal algorithmic notation, we have 3.68 plus 1.14. Line them up like this. We make sure that the dots are in a vertical line with each other, and then we add basically as normally. 8 plus 4 is 2, we carry a 1. 1 plus 6 plus 1 is 8, plus 1 is 4, and then the dot goes straight down into the answer for addition and subtraction. A few of these with pictures. We have this. So last time I started with the big end, and then I ran into a place where I had to regroup. Let's start with the little end. I have 6 of these little squares. 5 plus 4 is 9 of the rectangles, and then 1, 2, 3, 4, 5, 6 is my set of big squares. So I get 6.96. Or, in other words, 2.4 plus 4.56. I line up the dots. I put in a 0 where I need to fill in the spaces. 0 plus 6 is 6. 4 plus 5 is 9. 2 plus 6, or sorry, 2 plus 4 is 6, and the dot goes straight down into the answer. We want to draw these. We have 0.3 is 3 rectangles, 0.5 is 5 more rectangles, and altogether we have 8 rectangles. 3 rectangles plus 6 squares gives us 3.36 as our answer. 1, 2, 3, 4, and 5. 4 groups of 10 5 ones plus 2 groups of 10, 9 ones. You can regroup, move 5 of these over. I have 4 over here. This gives me 1, 2, 3, 4, 5, 6, 7.4. Right, 0.7. Subtraction works the same, except that we're going to cancel. So I have this number here, and I'm canceling this one. I need to cancel 4 blocks. Leaves me with 4 little blocks. Cancel one of these rectangles, which leaves me with 5 of them. Then I cancel one of the big blocks. That gives me 2 left over. This is the same as saying 3.68 minus 1.14. 8 minus 4 is 4, 6 minus 1 is 5, 3 minus 1 is 2. The dot goes down straight into the answer. So in here, it looks like we have to borrow. So I want to cancel 6 units, but I don't have any. These aren't units, these are hundreds. I should call them that. I want to cancel 6 hundredths, but I don't have any hundredths in the number I'm taking from. So I'm going to take one of these groups of 10, break it into 10 ones, and then cancel 6 of them. So I have 4 groups, I have 4 hundredths. Now I want to cancel 5 tenths, but I only have 3 tenths, so I need to take one of these units and break them into 10 rectangles. Might look short, but that's uh, called an optical illusion. They're actually all exactly the same size. I cancel 5 of them, so I cancel those, and I'm left with 8, 5, and these 3. This is canceled, broken into tenths. Then I need to take away 1, 2, 3, 4. Here, I cancel 1. I'm left with um, 3 negatives. So, yeah. So I have 0.84 positives and 3 negatives. I need to cancel these positive 0.84 with the negative 0.3. So I have one of these that I cancel 8 from, or more from. I'm left with 6 negatives. 2 of these, one of these that's negative, and then 6 of the hundredths that are negative. Or we could write this as this is 2.4 minus 4.56. Take the bigger number we put on top, minus, we subtract the smaller number from it, putting a 0 in as a placeholder where we need to. 6 minus 0 is 6, 5 minus 4 is 1, 4 minus 2 is 2. Put a dot, and since the bigger number was negative, my answer is to also be negative. Negative 2.16. Draw some more pictures. I want to draw 5. It's this many, I think. 5 of them, and then we want to subtract 3. So maybe change the color on this. Take away 3 of these. That leaves me with, which again, I could line up the decimals, subtract, and get 5 minus 3 is 2. The dot goes straight down. Same answer either way. I think I kind of like the different blue. You'll have to draw the rest of these, but you can also 3 minus 0.06. I put a 0 as a placeholder. I have to borrow. 10 minus 6 is 4. 2 minus 0 is 2. The dot goes down. Should end up with 0.24 when I draw this on my chart. I'm going to let you do the rest of the drawing of this section by yourself. You determine a rule or rules for adding or subtracting decimals. Yeah, you line up the decimals and then you subtract as normal and you put the answer, put the decimal and the answer straight directly down beneath where it was in the question. Let's do this one. We have 3.4201 plus 2.5. The dots have to be lined up. Put some zeros as placeholders. Go 1029.6. And our answer is 6.920. I'll do part of this one. I'll add this to this, and then you can add the 4.1 later. Line things up, we place a 0 where we need to. 7, 18, 9 plus 1, 10. 1 plus 3, 5 is 9. 5, 6. Get this. 0. And then your job is to add 4.1 to that. Put in the zeros where you need to get placeholders. And I'll let you do the rest of that one. This is a nice description of how to subtract. So we have 6 minus 3.15. We want to put the bigger number on top. And we need to put zeros as placeholders as necessary. I need to borrow. I take 1 from 60. 9. 10 minus 5 is 5. 9 minus 1 is 8. 5 minus 3 is 2. The dot goes straight down. Our answer is 2.85. Let you do the other one on your own. When the signs are the same, you use your adding algorithm. When the signs are different, this one, we're going to use the subtracting algorithm. Put your bigger absolute number on top, smaller one on the bottom. 4 minus 0 is 4. 5 minus 6, I need to borrow. 15 minus 6 is 9. 2 minus 2 is 0. Dot goes straight down. This is the absolute value of my answer. Since the bigger number was negative to start with, my answer is going to be negative 0.94. I'll let you do the other one on your own. Now we have some word problems. Opening stock price was $45.98. By the end of the day, the stock had increased to 51.06. By how much did the stock go up by? Did the stock go up by the end of the day? So put the big number on top, a little number underneath. Subtract, borrow. 9. This turns into 16. 16 minus 8 is 8. 9 minus 9 is 0. I have to borrow. Minus 5 is 5. 4 minus 4 is 0. Dot comes straight down. Went up by $4.08. Module 6.4. What was Samuel sad today? So we'll continue with this. Now we're going to multiply and divide. Really, multiplying is going to be the same as multiplying with whole numbers was, with the exception that we need to track where the dot goes in the answer. You don't line up the dots like you do for addition or subtraction. You just multiply as normal, and then you have to place the dot correct. Um, let's explore what this looks like as fractions. This is going to be 9/10 times 4/100. If I multiply this, I get 9 times 4 is 36. 10 times 100 is 1,000. So I get 0.036 as my final answer. The way to do that with our normal multiplication algorithm is like this. 9 times 4 is 36. 9 times 0 is 0. 0 plus 3 is 3. And then I say there are 1, 2, 3 digits that are to the right of the decimal. So I have to place a dot and a 0 so that these numbers go, so that I have 3 digits to the right of the decimal in the answer. There are 3 digits to the right of the decimal in the question. There need to be 3 digits to the right of the decimal in the answer. That'll go for any of these. Here's a nice picture of how that works. This represents 0.4 because it's 4 rectangles. This represents 0.5 because it's 5 rectangles. They're turned on their sides. Where they overlap is their product. Remember how the area of a rectangle equals the length times the width? Well, this is the width, and this is the length. So when I multiply those, I get this region that I'm coloring is the area. And this region has 20 hundredths in it, which is the same as 2/10. So I'm going to multiply the 0.3 and the 0.6. Here's 0.3. Here is, let's see, that's 0.6 is here. And this is going to equal 1,800. I put the dot there. Just like 0.3 and 6, when I multiply, I get times 6 is 18. There are 2 digits to the right of the decimal, so I put the decimal point there. What I get from the picture. Okay, I have 4 times 0.7. I draw 0.7 is this region with 7 vertical columns, and I do that over and over again, 4 times. Count, I have 28 tenths, which I can regroup as 2.8. Same as doing 4 times 0.7. 4 times 7 is 28. There's 1 decimal point past the dot. So I put 1 decimal point past the dot. We're going to notice that multiplying by 10 moves the dot over 1. Multiplying by 100 moves it over 2, just like there are 2 zeros in it. Multiplying by 1,000, there are 3 zeros, so the dot moves over 3 positions. And multiplying by tenths, hundredths, thousandths, any, these are called negative powers of 10, where you're dividing by 10 instead of multiplying. Any of those move the decimal point the other way. So this is going to move the decimal point over 2, 145.6. And likewise, this is going to move dot over 4 position. Have 1.458. The dot move 1 to 4 position from its original place. Yeah, that's where it goes. Space there doesn't belong there. Pattern is multiplying by powers of 10 moves the decimal point 1 spot for each of the 1 spot for however many tens you're multiplying by or however many tens you're dividing by. We're going to multiply. We have 0.005, 16.1, multiply 5 times 1 is 5, 5 times 6 is 30, 5 times 1 is 5, plus 3 is 8. There are 1, 2, 3, 4 digits past the decimal, so I need to put a placeholder 0 to make that happen for us. Answer. We have a negative times a positive, our answer will end up being negative 8.3 over 0.4. Multiplying them together, 3 times 4 is 12, times 4 is 32, plus 1 is 33. I'm going to put that negative sign there. And there are 2 digits past the dot, so I'm going to put a dot there. That's plus negative 3.3. Here, the multiplying by 100 will shift the decimal point over 2. It's negative 0.34. We can drop off being zeros. This one together, I have, this is a negative times a negative times another negative. 2 of those negative signs will cancel, but the last one won't, and so our answer will be negative. 0.07 times 0.07 gives me 49, but I have to have 2 placeholder zeros because there are 4 points to the right of the decimal point. I take this number, 0.0049, multiply it by 7, and I get 343. But now I have I have 6 digits past the decimal point, so I need to put 3 placeholder zeros. That gets me that number. But my number should be negative, so my final answer is negative 0.000343. That's slower. 7.07 times 0.004. 7 times 9 is 63. 7 times 8 is 28. Plus 6 is 30. And then I move the decimal point and make it negative. Dividing by a decimal works. The picture of taking 0.3 and dividing it by 0.03. This is a group of 0.03. This is another group of 0.03. We go through until we take the whole 0.3, break it up into pieces that are size 0.03. There are 10 groups of that size. This one we have 0.48, so we have 4.4, and we have, there's the 8. We want to divide this into groups of 0.12, so here is 0.1, 0.2 goes with it. There's another 0.1. That 0.2 go with it. And here is another 0.1. Stripes and patterns. 2 dots that go with it. And then we have the last group of more to go. So this gives us, there were 4 of them. Now, if I want to do this using long division, so easiest way to do this is going to be, I want to move this decimal point away. I don't want to have a decimal point at all in the outside number, the divisor. So if I'm going to move this decimal point over to the right so that I just get 12, do the same thing on the left. If I move it the same direction and the same distance, I am replacing one problem with another problem that has the same answer. 12 goes into 48 four times. 4 times 12 is 48. Subtract and I get 0. That is my answer 4 with no remainder. 3.5 divided by 0.7. So I will color in. I'm just this is the part we were. So I have 1, 2, 3, and 5. In the parts I didn't color, I want to divide these into group 7. So that's 7 vertical pieces. That's here is a 0.7. 4, 5, 6, 7. Here's another 7. 1, 2, 4, 5, 7. Other 3, 4, 7. 1, 2, 3, 4, 6. This gives us this equals. If I take 7 and divide 3 by it, that's the same as taking 7, moving the dot over 1 to the right. 7 goes into 35, happens 5 times. That's on our multiplication table. 7 times 5 is 35, so I'm not even going to do the long division, but 0.7 into 3.5 is the same as 7 into 3 into 35. Have this chart here is analogous to the one we did for multiplication. Instead of multiplying by tens, we're dividing by tens, and we notice that multiplying by 10 and dividing by 10 move the decimal point in opposite directions. Multiplying by tenth or a hundredth moves the dot in the opposite direction as dividing by a tenth or a multiplying by tens or dividing by tenths move the decimal so the number gets bigger, and dividing by hundreds or dividing by hundreds or multiplying by hundredths, they both make the number smaller, moving the decimal. So those are patterns to note. I'll let you fill out the charts. So let's do some long division. 4 goes into 21 5 times. 5 times 4 is 20. Subtract, I have 1 left over. Bring down to 1. 4 goes into 11 2 times. 2 times 4 is 8. 11 minus 8 is 3. Bring down to 3. 4 goes into 33 8 times. 8 times 4 is 32. Subtract, I have 1 left over. Bring down to 0. 4 goes into 10 2 times. 2 times 4 is 8. Subtract, I have 2 left over. Bring down to 0. 4 goes into 25 times. 5 times 4 is 20. Subtract, and I get 0. No remainder. So this here is my answer, except that I need to know where to put the decimal point. Now, since I went into the 21 in the first step, and I wrote the 5 above the 1 in that, I now have this lined up so that I can just push that decimal point right up into the answer like that. Okay? So if I have a number, some number here, and it goes into some other number, if I'm going into the first 2 digits, I want to write my digit above the 2 here. If I'm going into the first 4 digits, I want to write my number above the 4 here. And as long as I do that, then when I get to the decimal point, I can just push that decimal point up into the answer and get the right number. If I feel uncomfortable with knowing where to put the decimal point, I should practice, and the best way to practice is going to be do the division problem, whatever number you got and whatever number you're dividing by, multiply those together and see if you get the um, the dividend. So multiply the divisor and the dividend sorry, the divisor and the quotient together to get the dividend. Show you over here. This is 0.99 into 2.067. I'm going to move the dot over 2 places. This becomes 99 into 206.7. 99 doesn't go into 2. It also doesn't go into 20, but it does go into 206, and it does that twice. So I'm going to put the 2 above the 6 because I went into 3 digits here, and so I need to have the number of times I'm going into the number I'm dividing above the third digit. I went into 3 digits. I need this number above the third digit. 2 times 99 is 198. I subtract. I get 8 as a remainder. Um, Borrow. 16 minus 8 is 8. 19 minus 19 is 0. That 7 comes down. I say, does 99 go into 87? No. Bring down another 0. Does 99 go into 870? Yes, it goes in 8 times. 8 times 9, 99 is 792. I subtract. I get 78. And I bring down a 0. And I can keep going. 99 goes into 787 times. It goes in 693 times. And I get 83, or 87 as my answer. Bring down a 0. This goes in 8 times, and I'm getting into this repeating pattern. 8, 7, 8, 7, 8, 7. If I keep going, it'll keep giving me 87. I go into it 7. I go into it 8 times. I have a remainder of 78, which becomes 780, which I go into 7 times. Gives me a remainder of 87, which I then put a 0 on. And this number is the same as this number, so I just keep going through the cycle. Anyway, I have this number here, and this dot is in this place, and I lined up my numbers correctly, so this dot will go right there. 208, 2.08, 787878, and so on. If I feel uncomfortable with where I put the dot, I can always round my numbers. So this rounds to, we don't need to round precisely. We just need to round to one significant figure. So I round this to 2. I round the bottom to 1. 2 divided by 1 is 2. So 2.08 is close to 2. If I did it wrong, I might get something like 20.8. And I'd say, oh, wait, 2 is not close to 20. Or I might, if I did it wrong, get like 0.0028. Sorry, 208. And say, oh, well, that's not close to 2 either. I need to make sure that when I do my approximation, I get a number that's in the same order as my actual number. So this is in the ones place, that should be in the ones place, not the tens place, not the thousandths place. And that can help me know where to put the dot as well. Let's do another one. Those are converting fraction. Like another decimal. Oh, let's do this one. So this one they've already they've worked it, so we're not going to necessarily do the long division part. But notice that they changed the 3.3 into 33, just like I would. This 0.15 becomes 1.5, just like I suggested. You should change to non-decimal numbers in this position. They did their division and they get 0.0454. Now, they probably put the decimal in the right spot, but if I wanted to check, I could do this. Instead of doing 0.15 divided by 3.3, I could round to be 0.2 divided by 3. Okay. Then I put my number 0.2 in the fraction and 3 out here. 3 goes into, well, 3 doesn't go into 2. So I'm going to have to put a 0. And so 3 goes into 20 6 times. I need this 6 lined up with this 0. I need this dot then to go straight up to here. And I need a placeholder to keep the dot separated from the 6. So this rounded answer has its digit, it's in the hundredths place. So when I look over here, is my answer in the hundredths place? And it is. So since it lines up nicely in the easy problem, I feel pretty good about my decimal placement in the hard problem, in the actual problem. Let's continue. So, write the fraction as a decimal, leave an exact decimal form. So I have this fraction here. If I multiply the top and bottom by 5, I get 25 over 100, which is equal to 25 hundredths decimal form. I also could do division if I want to do 20 goes into 55. Well, 20 doesn't go into 5, so I have to put a dot and a 0. 20 goes into 50. Dot goes, goes there. 20 goes into 50. Now I have, see, my answer is lined up. 20 goes into 50 times 2 times 20, 40. In fact, I have 10 left over, bring down a 0. 20 goes into 100, 5 times 20 is 100. 0 remainder. Notice that this is the same answer as that. So this here, there's no nice way to turn a 6 into a power of 10 like we could in the last problem. So we're going to have to do division. 6 goes into 5, but 6 doesn't go into 5, so we put a 0 and a dot and a 0. 6 goes into 50 8 times. 8 times 6 is 8. Subtract and get a 2 as a remainder, bring down a 0. 8 goes into 23 times. 3 times 6, 18. It has a remainder of 2. We bring down a 0. This is the same number as this, so now we're stuck on our loop, which means we're going to repeat. Our answer is negative 0.83 with the 3 repeating. This bar on the top means that it repeats the digits underneath of it. If I had multiple digits that repeated, like this one, I could write it as 0.12 with the bar over the 1 and the 2. If not everything repeats, then I can do, maybe I have like 1, 2, 3, 4, 5, 4, 5, 4, 5. This. Then I write the part that doesn't repeat. And when I get to the part that does, I put the bar over just the part that repeats. Okay. So, write the mixed number as decimal, round to the nearest hundredth if necessary. The mixed part will stay the same. We're figuring out what comes afterwards. 7/9 we're going to figure out by doing 9 going into 7. 9 times 7, sorry, 9 doesn't go into 7. You have to put a dot, 0 there now. 9 goes into 70 7 times. 7 times 9 is 63. We have a 7 as a remainder. Bring down a 0. 9 goes into 70. Well, same as before. We have a repeating 7. Write the mixed number as a decimal, round if necessary. Well, we'll just write it exactly. 1.7 repeating. Negative 1.7 repeating. Okay. Here we have 8 goes into 3. 8 doesn't go into 3. So I have to put a dot, and a 0. 8 goes into 30. 3 times 8 is 24. Subtract, we have 6 left over. And a 0. 8 goes into 60 7 times. 7 times 8 is 56. Subtract, 4 left over. Bring down a 0. 8 goes into 40 5 times. 5 times 8 is 40. Subtract, we get 0 left over. So we have 3.375 is our answer. Now we have some word problems. Quality chocolate sells for $14.95 per pound. How much would it cost to purchase 3 pounds of the chocolate? 14.95 times 3 by 5 is 15. 3 by 9 is 27 plus 1 is 28. By 4 is 12 plus 2 is 4. Times 3 is 30. There are 2 digits past the dot, so we put the dot there. Costs. Wait, 3 times 4 is 12. 1 there. Times 3 is 3 plus 1 is 44.85. Car travels this far on that far, sorry, this far on that many gallons of gas. How far will it travel on 1 gallon of gas? So it's traveling 994 on 35 tanks of gas. If we divide the miles by the gallons, we can get how many miles it went on each individual gallon of gas. 35 goes into 92 times. 2 times 35 is 70. Subtract and get 29 as a remainder. Bring down the 4. 35 goes into 294. Well, let's see. 35, 70, 105, 140, 175, 10, 45, 80. That's 1, 2, 3, 4, 5, 6, 7, 8. 8 times. 8 times 35 is 280. Subtract, we're left with 14. We bring down a 0. 1, 2, 3, 4 times. We have 0.4. 28.4 miles per gallon. Okay, there are 2 more sections, and so we will cut the video here. Measures of central tendency and variation. So this is the beginning of the stuff that will not be on the quiz. It will be on the exam, because on the exam you get a calculator, but it's not going to be on the quiz, because on the quiz you have no calculator. And really, it's just, it takes too much work to write these types of questions in ways that don't need a calculator. So it's kind of cruel to make you do it by hand, and it's kind of a pain to come up with easy questions that don't need a calculator. So we don't worry about that. We will give you questions that need a calculator, but you will have a calculator. And we will cut there. I hope you're having a good day, and I will talk to you next time.